In this module, we focus on the proof behind your eIDAS solution. You'll see which evidence must be captured, how to structure audit trails, and how timestamps, validation, and preservation services support compliance and future dispute resolution. When we architect an eIDAS solution, smooth onboarding isn't enough. The bank must also be able to prove in detail what happened, who actually acted, how were they verified, what exactly did they see and consent to. This burden of proof is what turns operational success into legal defensibility. In an eIDAS-style onboarding and signing solution, evidence isn't just logs, it's a lifecycle. First, raw data is captured while the user is identified, authenticated, and signs who did what, when, and with which assurance. Next, those events are consolidated into structured records that tell a clear end-to-end story. Finally, those records are preserved for years, so integrity, availability, and readability are guaranteed, even during disputes or regulatory reviews. Within identity proofing, the first pillar is evidence. Banks need strong, layered proof that the person is real and the document is genuine. That includes the raw ID data, the surrounding context of the session, and the verification results. Together, these elements support eIDAS assurance levels and future disputes or audits. Consent and contract acceptance are about proving two things: what the user saw and what they agreed to at a specific moment. You start by capturing intent, clear terms, and explicit action like ticking a box and clicking confirm, and any required declarations. Then you create a durable record: who the user was, which contract and privacy notice versions applied, the exact timestamp, and a cryptographic hash. Together, intent plus record make consent defensible and eIDAS ready. When a qualified signature is created, you still need to know if it's trustworthy at that moment. The system first checks the signing certificate with the issuing authority to see if it's expired or revoked, usually via OCSP or CRLs. It then confirms that this authority is actually a qualified provider by checking the EU trusted list. Finally, it packages the result into a validation report the bank can rely on later in audits or disputes. Event correlation is the golden thread that makes onboarding and signing legally defensible. First, the person is verified. Later, they read information and actively agree to it. Finally, a cryptographic signature is created. Correlation means you can prove these three events belong to the same human in the same session for the same transaction. In disputes, this linkage lets the bank show that this identified person really consented and really signed. Think of the evidence package as a single story of the transaction that you can replay years later. You want all critical pieces in one logically linked bundle: who the person was at onboarding, how they were identified, what they agreed to, the exact document version they signed, and how the signature was validated at the time. Design your system so this package can be reconstructed or exported reliably in a regulator-friendly format. Long-term preservation is about keeping signatures and evidence trustworthy, even as cryptography weakens over decades. Algorithms age, keys get shorter relative to attack power, and what was secure in 2025 may be breakable by 2045. To counter that, a preservation service periodically wraps the original signature and all validation data in a new, stronger archival timestamp. Each renewal extends this golden thread of trust, so the bank can still defend that signature far into the future. In an eIDAS onboarding solution, treat operational logs and evidence logs as two distinct products. Operational logs help engineers keep systems alive. They're high volume, noisy, short-lived, and can rotate quickly. Evidence logs support lawyers and regulators. They must contain carefully structured correlated facts, kept unchanged for many years on worm-style storage. Mixing the two usually fails both goals. Operations becomes unwieldy, and compliance evidence becomes unreliable. For eIDAS compliance, logs must be both complete and tamper-evident. Think of each log entry as a link in a cryptographic chain. Hash chaining means that changing any past event breaks the chain and becomes detectable. Append only, write once storage ensures events can only be added, never silently removed or rewritten. On top of that, strict role-based access control limits who can view or export logs, protecting sensitive identity and signing evidence. In eIDAS onboarding, you're constantly balancing two opposing tensions. On one side, AML and eIDAS expect you to prove everything: who the user was, what they saw, what they agreed to, and when. On the other side, GDPR pushes you to keep only what is necessary. Architecturally, you reconcile this by pseudonymizing identifiers, storing references to heavy artifacts instead of raw biometrics, and enforcing clear retention and deletion rules from day one. You can think of this blueprint as a pipeline for trust. First, every system publishes security and business events onto an event bus, so nothing important is missed. Those events flow into a centralized SIM where they're normalized, correlated, and protected. From there, key facts are extracted into an evidence repository that's optimized for audits and disputes. Finally, a preservation archive takes care of long-term validation, so signatures remain provable for decades. To make your onboarding and signing solution truly defensible, think in 3 layers. First, correlate all the evidence. The proved identity, each consent, and the qualified signature must be tightly linked by a single transaction context. Second, store that bundle immutably, using worm-style protection and hash chaining so nothing can be altered unnoticed. Third, plan for decades. Apply LTV validation and preservation services, so your proofs survive algorithm changes and still stand up in court. You've now seen identity, qualified signing, and evidence as separate building blocks. Next, we'll snap them together into one end-to-end architecture. You'll follow the full customer journey and see exactly how these components cooperate in a real banking solution.